Okay, good morning, everyone. So, as the part of advanced trainings for the softwares, today we have here for the design of industrial shed. So, we have learned the subject that is design of steel structure. In the design of steel structure, we have learned the or we have designed the so many element of the industrial shed. So, as a part of the uh, design in the structural engineering. So in the steel structure, we have to design the industrial shed, and that industrial shed made up of the steel structural element. So there are two main design in the structural engineering. One of the steel structural design and RCC means reinforced concrete design. So here today we will see the how to design the industrial shed means industrial building by using the steel structural member. So we will cover here some of the important parts required for the design of industrial shed, and how to calculate the loads for the design of industrial shed. And we will take one small example, and by using this we can design the particular industrial shed building uh, uh, by limit state method in the design of steel structure. Okay, so here we have to design the roof truss. In the industrial shed building, we have to design the roof truss. It means whatever roof, roof is nothing but the topmost part of the any type of the building. So that roof made up of a truss in the steel structure, and that truss we have to design. So while the designing of the roof truss, what are the important parts we have to consider and what we have to design in this particular industrial set. So if you see here, the first is the assessment of dead load, live load and wind load. So very important part in the design of steel structure or design of industrial set, we have to assess the loads. So first is the dead load, live load and wind load. So how to assess this particular types of load, that we have to see here. Then in the industrial set, we have to design the purlin. Again, in the industrial set, we have to design the members. It means whatever triangular members are in the truss, that members we have to design. uh, uh, that member may be a tension member, compression member. So we have to follow the procedure of design of tension member and compression member, and we have to design the members. And again, we have to provide the detailing of the joint and supports. It means truss is made up of a triangular shape. We have seen the truss element. So that truss are made up of the uh, triangular element. It means triangular element connected each other, and one of the truss is formed. So in the design of roof truss, if you see the here picture, if you can see this is the truss, and that truss is made up of the uh, steel members connected to each other in the form of triangular shape. Okay, so then what is industrial shed, that we will see here first. The industrial shed is the low-rise building. If you see the uh, RCC building, so we can construct the RCC building G plus 1, 2, 3, 10, 20, 100-story building. But here the limitations are there. For the industrial shed, there are limitations are there. So industrial shed is the low-rise structure, and this characterized by the low height. So here we have to consider while the design of industrial building. So there are we have to provide the truss for the industrial shed building, and that truss are in the triangular formation of the steel sections, in which the members are subjected to axial forces. So axial loads are applied on the particular members. So axial load may be in the tension, axial load may be in the compression. So this is the roof truss. So there are two types of the roof trusses. If you see the here pictures, the figure 1 is showing the plain truss and figure 2 is showing the space truss. So what is difference between the plain and uh, space truss? So here plain truss is nothing but when the external load is applied in the plane of truss, we can call as a plane truss. Plane truss means if you see in the one direction view is here in the plane truss, and in this space truss we have the taken the photograph, or we are seeing the truss in the plan. So here plane truss is nothing but the external load lies in the plane of the truss, we can call it as a plane truss. And whereas the space truss, in the space truss, the load lies in the three-dimensional plane. So we can term it as the space truss. So depends on the loading, the load acting in the plane, we can call plane truss, and load acting in the three-dimensional view, we can call it as a space truss. So this is nothing but the roof truss and their types of the trusses. So here we can see the various types of the or various parts of the particular roof truss. It means while designing the industrial shed, topmost part of the your shed is the roof truss, and above roof truss sheet is there. There may be GI sheet or AC sheet. So the sheets are resting on this particular roof truss. So the roof truss components are, we have to remember, and that part components we have to design, and how much or which type of load the particular component is taking, that we have to see here. So if we see here particular image, so if you see the particular image, the image is showing the components of the truss. So the components of truss, if you see here, uh, here first component here written is the principal rafter. So the principal rafter is the inclined member. If you see here, if you see my cursor, the principal rafter is an inclined member. So the inclined member that take the compressive load. So what is principal rafter? The principal rafter, it is the top chord of a truss subjected to compressive load due to gravity load. If purlins are supported at nodes, it means on the principal rafter, the purlins are the on the principal rafter, there are purlins are resting on the principal rafter. So what is principal rafter? It is the top chord, top inclined chord of a truss subjected to compressive force due to gravity, and the purlins are rested on the principal rafter. So if you see here, this is the inclined member, topmost inclined member that shows the principal rafter. Now the next is the principal tie. If you see the bottom chord, what is what is principal tie? The principal tie, we can call as a tie member also. In the roof truss, we can call for the principal tie as a tie member also. So what is the principal tie? The lowermost chord of the truss is known as the principal tie, and this principal tie or tie member carries a tensile load due to the gravity loads. So first is the principal rafter, that is inclined topmost member. Then lowermost tie or tie member we are calling, that is the principal tie. Then third component part of the roof truss is the strut. So the strut, the member, what is mean by strut? If you see the picture, we have seen or we have learned in the design of steel structure also, the strut member, the member of a roof truss other than the principal rafter or other than the principal tie is subjected to compressive load. It means if you see this incline or vertical, if you see here strut member, So there here not showing the strut member. Just minute. Uh, all the vertical members of a truss, all the vertical members of a truss are we called as the strut member, and that strut member again carries a compressive load. It may be sometimes tensile load also. Then fourth component of the or fourth part of the roof truss is the sling. The members of roof truss other than the principal rafter subjected to tensile forces. It means whatever inclined members, if you see here, sling is written, whatever inclined members of a roof truss are there, that inclined members are subjected to tensile force, and these members we are calling as a sling members. It means other than principal rafter and principal tie, whatever inclined member in the roof truss, that we are calling as a sling, or we are calling as an inclined member also. And that inclined member subjected to tensile force. The next component part of the roof truss is the purlin. So the purlins are the flexural members which are rested on the principal rafter. As we have discussed, the purlins are rested on the principal rafter, and above the purlin, the seats are there. The seat may be AC seat or seats may be GI seats. That seats are rested on the purlin, and purlins are rested on the principal rafter. The principal rafter is the inclined topmost member. So what is purlin? So the purlin is the flexural member carrying a roof or roof covering. As we have discussed, whatever GI seats are rest or AC seats, that GI seats and AC seats are rested on the purlins, and the purlin is supporting to the roof covering, means GI or AC seats, and distributing the load on the truss. It means transferring to the principal rafter, and again principal rafter is transferring load to the on the another members. Then last component of the roof truss is bracing. So what is bracing? So here the bracing we are providing in the industrial shed or in the roof truss, the member of a truss which makes it suitable for accidental load out of plane load or lateral load is known as the bracing. It means what? See, sometimes what happen, the roof truss, all the parts, it means principal rafter, tie member, incline member, strut members are there, but we are providing the truss in along the length for the industrial building. So we are providing multiple trusses. So for the multiple trusses in the horizontal plane, we are providing the bracing. It means whatever load coming on the roof truss or wind force may be there, dead load, live load may be there, that load transferred by the bracing ultimately finally. It means एका ट्रस वरचा लोड हा दुसऱ्या ट्रस वरती ट्रान्सफर करायचं काम सुद्धा ब्रेसिंग करतात. इट मीन्स द ब्रेसिंग्स आर provided truss to truss or column to column. It means if the additional or accidental load maybe comes, then the bracings are important part, and that transferring the load to the truss to truss or column to column. So here we can see the bracing in the truss. जे ट्रस मधील आपण हे ब्रेसिंग बघतोय की जे एका ट्रस वरचा लोड दुसऱ्या ट्रस वरती ट्रान्सफर करतात. So these are the components parts of the roof truss. So now see the various types of the roof truss. So the depending upon the span of truss, it means we have to provide industrial shade. It means for any room or for any building, there are two dimensions are there main in the plan, x direction and y direction, means width and length is there. So here in for the width we are providing the truss. So depending upon the span of truss, we are providing the type of particular truss. So if you see here, in this picture, there are shown the some of the various types of trusses. So Pratt truss, Howe truss, Fink truss, fan truss, Fink fan truss. So these are the some types of trusses we can provide for the industrial building or for the industrial field. Okay. So the very important part of the design of roof truss or industrial shed is the load. So now I will compare with the software and regular load analysis. So software required input. So when or while we are designing the industrial shed by using the software, so we have to provide the input data. That input data is nothing but the load and load combinations. So that we have to provide. So first we have to analyze the loads. The load may be dead load, live load, wind load, or any type of load. And we have to take the combinations of load. It means while we are designing the any particular type of industrial shed, we have to give the inputs of the load first, and that we have to calculate. So by we are designing the industrial shed by using software. For software also we have to provide the loads, and that loads we have to provide by the calculations. So how to calculate the particular type of load for the designing the industrial shed? So first type of load we have to consider initially, that is the dead load. So dead load is the nothing but the self weight of the structure, or we can call it as includes the weight of roofing material, weight of purlin, weight of bracing, and weight of truss. So in the dead load, there may be four main dead loads we have to consider. The weight of roofing material, it means the topmost part of the your roof truss is the roofing material, means AC sheet or GI sheet. Below the AC sheet or GI sheet, purlin may be there. Below the purlin, truss is there, and bracings are provided truss to truss. So these four major part or components of truss we have to think as a dead load, and we have to now take the dead load of particular, each of particular. So roofing material. So we have the roofing material, AC sheet, GI sheets available in market. So we can take the load of particular AC sheet of GI sheet in Newton per meter square. Then purlin we can calculate the load in Newton per meter square, bracing and truss. So these four loads we have to take as a dead load. So the unit weight of different material are given. It means self weight of this particular roofing material purlin is given in the IS 875 part 1. So the IS 875 part 1 is used for the calculation of the dead load. So here written, the weight of bracing may be assumed between 12 to 15 Newton per meter square. That is given in the your IS 875 part 1. Then similarly, weight of purlin we are assuming 80 Newton per meter square to 120 Newton per meter square. Then weight of truss we can calculate by using the formula span by 3 plus 5 into 10 that we have learned also. So in this way we have to calculate the dead load. So dead load nothing but weight of roof covering, weight of purlin, weight of bracing, and weight of truss. So these four weights we have to take, and we have to add these four weights in the Newton per meter square, and then we will get the total dead load which is acting on the particular roof truss. So then second type of load is the live load. So second type of load is the live load. So for the live load calculation, the IS 875 part 2 is used. So IS 875 part 1 is used for the dead load, and IS 875 part 2 is used for the calculation of the live load. So how to calculate live load? So see, in the IS 875 part 2, there is one table is given. So this table includes here, first column is the roof slope, second column is the assess, third column is the live load. So the roof slope, the less than or equal to 10 degree roof slope is there, or greater than 10 degree. So assess, it means less than 10 degree slope assess is provided, and greater than 10 degree slope assess is not provided. It means the more slope is there, we cannot go on the roof truss. If the less than 10 degree slope is there, we can go on the particular uh, roof top of the roof. So now, if the roof slope is less than 10 degree, the live load is 1.5 kilonewton per meter square of plan area. It means we have to take the live load when the less than 10 degree slope is there, 1.5 kilonewton for per meter square. And if greater than 10 degree slope is there, then we have to take the live load 0.75 kilonewton per meter square of plan area. So, and the finally we can calculate the live load by using this formula 750. 750 is nothing but here this 750 kilonewton. This 0.75 kilonewton we can convert into Newton, then 750 minus 20 into 10 minus 10 theta minus 10 degrees. So 10 is nothing but this roof slope, and theta actually provided theta. So by using this, we can calculate the live load in Newton per meter square. And for the calculation of live load, IS 875 part 2 is provided. So then next is the wind load calculation. So very important part of the design of roof truss or industrial shed is the wind load. So more amount of load, whatever load is acting on the roof truss, in the more amount, that is the wind load. Because you have seen many more industries, you have seen, not visited, but you have seen from the outer side area. So the very long and width and length of this particular building is very high. So the tremendous wind pressure acting on the particular roof covering area. So that we have to consider in the while calculation of the wind load. So what is wind load? So wind load are the most critical loads in the design and analysis of the industrial roof truss. The design wind pressure, the design wind pressure of the roof or wall cladding must be designed using the pressure difference of the opposite faces. It means whatever faces are there, so we are providing the two side slope for the industrial shed. So on this particular faces, um, the wind pressure is acting on this two direction. So for this two direction, we have to analyze the, or we have to calculate the design wind pressure. And so the wind load is the most critical load in the design of industrial shed. Okay, so finally we have to calculate wind force. How to calculate wind force? There is one of the formula for calculation of the wind force. So force F is equal to CPE minus CPI, the coefficient of pressure in external coefficient of pressure minus internal coefficient of pressure into area of the truss into designed wind pressure. So this is the formula. So here written where CPE external pressure coefficients, CPI internal pressure coefficient. So these coefficients are given in the IS 875 part 3. So IS 875 part 3 is used for the design of the wind load calculation. So when we have to calculate the wind load calculation for the calculation of load combinations, the IS 875 part 3 is required. So their coefficients are given as per the study. The IS code is designed, and in the IS code there are external wind coefficients or pressure coefficients and internal pressure coefficients are given. Then capital A is here nothing but inclined area of roof truss. It means we have seen the roof truss. So at the top the ridge is there. From the ridge we can provide the slope for both the side. So it means we have to take this inclined area, and then PD is nothing but the designed wind pressure. So that designed wind pressure is calculated depends on the wind velocity, basic wind velocity in this particular area. So in this particular area, how much wind velocity is there in the meter per second? Depend on the meter per second, we have to consider some factors, K1, K2, K3. These are the topographical factor, then risk factor. By using this particular factor, we have to calculate first design wind pressure. After the design wind pressure, we can calculate the design wind force. Okay. So here again written external pressure coefficients, internal coefficient, pressure coefficient. So what is external pressure coefficients? So external pressure coefficients is nothing but the external pressure and or pressure concentration coefficients for the pitched roof of rectangular clad building. It means as we discuss, we are providing the slope to the industrial shade or industrial building in the two side. So for the two sides, the wind pressure acting on a roof truss in the two directions on the particular industrial shade. So for this particular zone of the wind area, so we have divided the external wind coefficients, and that external wind coefficients are given in the table number 5 of IS 875 part 3. So that we will see in the next slide. Then internal pressure coefficients. So the internal pressure coefficients is depends on the permeability of the building. So what is permeability? So degree of permeability, it means how much flow of air coming inside and outside in the particular building. एखाद्या बिल्डिंगच्या इनसाइड आणि आउटसाइड मध्ये एअरचा किती फ्लो आहे, depends on that we have to take the internal pressure coefficients. It means we are calling as a degree of permeability, and that depends on the flow of air, that we are taking as a plus minus 0.2. So this is the internal coefficients. Then inclined area, as we have discussed, inclined area is nothing but the from the ridge to the whatever inclined area of the acting where the wind force or wind is acting on the particular inclined area, that area is the inclined area. Then next is the design wind pressure. So PDU, as we have discussed, how to calculate design wind pressure. So design wind pressure at a any height above the ground level, that is obtained by the relation that is the PZ is equal to 0.6 VZ square. So PZ is the designed wind pressure in the Newton per meter square. So now V here, VZ square. So here VZ is here written, design wind speed VZ. The VZ is calculated by VB into K1 into K2 into K3. If see here my cursor, how to calculate the designed wind speed, VZ is equal to VB into K1 into K2 into K3. So what is K1, what is VB, what is K2, and what is K3? So here VB is the basic design speed. And that basic design speed is depends on the your locality of building. So in the IS 875 part 3, they have given the basic wind speed in overall in the India. In the overall India, they have divided the zones of the area, and they have given in the IS 875 basic wind speed for the particular area. It means for Delhi city, how much basic wind speed you work, for Pune region, for uh, uh, Solapur region, Latur region, Nagpur region, Aurangabad region, or Bihar, Patna, Arunachal Pradesh. Overall, in the India, there are major cities are there where we are constructing the industrial shed. So they have given in the IS 875 part 3 uh, basic wind velocity. So that is VB. K1 risk level factor, K2 is the terrain factor, and K3 is the local topography factor. It means depends on the location of your building, we have to use this K1, K2 and K3. So some of the factors depends upon the height of building, some of the factors depends upon the your topography of the particular area of the building. So by using, we can calculate the VZ, and finally the VZ value, it means design wind speed, we can use into the PZ formula, it means design wind pressure, and we can calculate the design wind pressure. And that design wind pressure we can use here in the design for wind force. While calculating the wind force, we can use the design wind pressure, that is here PD. So if you see here picture or image, basic wind speed, as we have discussed in the India, we have segregated or we have calculated the basic wind speed for the particular city. So here cities are given: Agra, Ahmedabad, Ajmer, so Mumbai, Calcutta, Chennai, Jaipur. So all the cities are given for this particular city basic wind speed in meter per second. It means wind is moving in the on the roof truss, some of the amount of the pressure, and that is moving meter per second. So this is the basic wind speed. Then here one of the table is given. That table is table 2A. This table is given in the IS 875 part 3. So what is this table? So this is the external pressure coefficient, CPE, and that CP is depends upon the height of building and width of building. External wind coefficients are given in the IS 875 part 3, page number 16. But how to take this particular coefficients? So we can take this particular coefficient, depends on the height of building and width of building. It means we have to take H by W ratio. H is the height of building, and here if you see here image, H is the height of building and W is the width of building. So H by W ratio we have to take, and we have to by this calculation we have to take the coefficients for the design of industrial shed. Again here factors are given. Permeability factor K1, that is given again in IS code. Then K2 is the terrain factor is given. This terrain factor we have to take by considering the category 1, 2, 3 and 4. So while designing this particular industrial shed, we have to use the IS 875 part 3 for the wind load calculation that is available with you, and by using this you can take the particular K1, K2, K3 factor, these factors, and we can calculate the design wind speed. Then by using the design wind speed, you can calculate the